All right, let's see how this works. Excellent. All right, guys, I'm testing out a faster computer here to see how well this works. Let's see how it does. Okay, everything set up? Hey, Michael. Oh my gosh, you guys. Very, very nice to be back. What a crazy week, man. And I've had to deal a lot with these guys this week. Yeah, I'm pretty sure that you guys recognize what it is. But I'm going to go over this a little bit because there's some stuff that maybe you don't know about them. Let me adjust this camera a little bit, all right? I'm testing out a faster computer as well, and I'm testing right now. So if I don't appear to be following, it's because I'm looking at what you guys are seeing on YouTube Studio versus the lag time from what I do. And it looks like there's a lag of about 30 seconds. So I already done said something 30 seconds later when you guys finally see it. Oh, it's so weird. Okay, I'm going to see if I can get rid of that lag time. But anyway, guys, I want to go over these little guys right here. The Covidien 700 series sequential compression device, or SCD. And these guys here, they didn't used to be part of my department, part of my responsibility, but everything changes, you know? That's just how it is. And I had a whole cart of these delivered to my shop, and nobody knew if it was us or if it was this company called Agility that takes care of things. And Agility normally is contracted out for a lot of this menial type of stuff. And come to find out, we own these things, and now Biomed's going to have to start taking care of them. And it seems like I'm the only person that's got history with them and fixing them. So I figured I would go ahead and show them to you guys, and we're going to tear it open because I had a unit that came across my desk. It looked like a bomb went off inside it. It was complete components. Matter of fact, I have a few of the components floating around here. So anyway, since I got inside it, I thought, you know, these things are actually kind of cool on the inside. I should share that with you guys and do a teardown on it so you can see what's going on inside. But let's start with the basics. For those of you that don't know, this is a Covidien 700 series SCD, or sequential compression device. And what this is for is there's some ports on the back for two different hoses. So it can handle two different appendages, whether it's one arm, one leg, two legs, two arms, whatever. Depending on the size of the reservoir that it pumps up when you boot it up, it detects if it's going to be an anklet, like a little boot, if it's going to be a leg sleeve, if it's going to be an arm sleeve. And I think it can also detect pediatrics based on the size of the inflation chamber. So anyway, what these guys do is it's a sequential compression device. A lot of the other manufacturers out there only have one chamber, but these pneumatic connections right here, these will go to a sleeve. Hold on just a second. Let me get rid of this window. Okay. Anyway, these right here are 3 tubes that are pretty long. They're about, I don't know, 6 to 8 foot long, and they go to a sleeve which will slide over the patient's leg or their arm, and it compresses in sequence, and it actually forms a pump using your body's own anatomy. So if you guys haven't, if you haven't seen my video recently on hearts, well, in that video I explained that there's arteries and there's veins in the body, and veins are the blood vessels that are going towards the heart. Arteries are blood vessels going away from the heart. And there's a physiological difference between veins and arteries. Inside veins, especially in your legs, there's a whole series of check valves, okay? They're almost like the rubber pinch valves that you see, and they're throughout the tube, right? So what happens is when your body pumps blood, when you walk, your feet, I don't know if you guys know this, but your feet are natural blood pumps. And as you walk, you're actually squishing blood up your leg towards your heart. And since up your leg, there's a series of check valves, as you squish blood, it moves up to the next one, and the next one, and the next one, up until your torso, where it goes into your heart. So veins have check valves in them. So as the blood goes up, it can't go backwards, right? So that's why walking helps alleviate heart disease. A lot of people that have heart problems are people that sit for long periods of time for a career. And that's why they always say you should get up and you should walk around, is because your feet are natural blood pumps, okay? And the problem is with convalescent patients or patients that are immobilized, they're stricken to a bed, is that blood can tend to go stagnant because of poor circulation. And when blood is stagnant, it tends to form clots, okay? So these devices right here, about, 10 to 12 years ago, these became a standard of care. So when you go into a hospital as a patient, they will naturally, if you're bedridden, they're going to put one of these on you while you're in a bed, and it's going to squeeze your leg in different stages, and it's going to help move blood through your body. And so that's what this little device's job is. It's a sequential compression device. So it's just got a sleeve that squeezes in different stages, and it's quite simply enough. But these things are semi-smart, and they can have a lot of error codes. All right, and so there's some stuff that you can do as a technician to scavenge parts and get as many of these back in service as possible. And I'm going to show you guys some of that right here, right now. So let's go ahead and let's boot this bad boy up. You're going to see as soon as I plug it in. Okay, so one of the first things that I want you guys to notice is there is a charge indicator over here along with a battery status. And that is extremely important because a lot of the problems that are related to this device have to do with charging, not charging, or no power whatsoever. And we'll go into that in a little bit. So anyway, these things, it's recommended that they stay plugged in when they're in a depot, which means when they're on a rack just sitting there waiting to get deployed. It's best that they stay plugged in because they have a battery that charges. And when that battery gets low, these guys tend to have all sorts of crazy little quirks, all right? So I'm going to boot it up. I'm going to show you guys what it does. You can hear it testing the relief valves. It tests the motor to make sure it's not bound up, and now you can see that it's actually seeking to see what type of sleeve is on the patient. So it's inflating certain chambers under a certain amount of time, and it's based on the amount of time and the pressure that it reads back, it knows exactly what type of sleeve you put on. If it's an arm sleeve, if it's an anklet, if it's a leg sleeve. Okay, so there's your first error code right there. It says, hey, what the hell, man? You got no sleeve connected to this guy. That is a very common problem. And it's a very common problem because as you see the connectors right there in the picture, it's very often that they're damaged or that they are not connected correctly, often damaged. You can see in the illustration where the hard plastic meets the soft tubing, these things break there all the time. Okay, there's tiny little hose barbs that are in the hard plastic, and because of the ripping on the hoses, bending them, pulling them, whatever, they snap off the little cheap plastic hose barbs. So what you see there is the error code that you'll get when you have a defective sleeve or defective hose. So anyway, this is a very common error. So I'm going to go ahead and shut it down. Hold on. Hey, thank you. Hey. So let me show you around this bad boy. You can see I have a spring-loaded clamp. It does have a safety test knob for redundant grounding or for ground test. You got your 2 ports, and you have a filter up and under this guy. I'll show you that in a minute when we do the teardown. This here is also, it seems like it's a good design, but this is also a problem. This little cover right here, it's got 2 screws that hold it on. And the thing is it's got a 90-degree IEC cord plug, and it plugs straight into the body. But the problem is you can't access it unless you're a Biomed. So if it starts coming unplugged in here, which does happen quite often, then you're going to get error codes, no charging, won't power on, errors like that. Just because they had to put a cover with 2 screws. Now the other thing that breaks all the time on this is this handle. In fact, I'm starting to think it's a miracle that this one isn't broken. It always breaks right here. Always. And you can see why. I mean, even though it seems like it's a very durable material, it's very proud of the device. So anything that impacts it is going to hit, and it's all that stress is put right here on this knuckle. They always break right there. If it drops on the ground, all that stress is going to be right there on that elbow. So that's the Achilles heel of this device. The other thing is the screen will often also be bad. Even though it looks like it's a resistive touch screen, as far as I know, the functions are all done through these buttons right here. But anyway, let's go into a service menu and let's show you some of the secrets of this guy. A lot of technicians don't know this stuff, so that's why I'm going to do this video for you. When you get an error code, let's say this has been sitting for a while or whatever. Hold on just a second, guys. Ay. Oh, that's irritating. Hold on, I'm changing the name of the stream because it doesn't do it on its own. There we go. I apologize, guys. I should have had this set up beforehand, but it's not because I didn't even know how to change it. Okay. There we go. Sorry, guys. I had to change the name of the stream because people are going to be like, what the hell? He just did that topic. And I realized that. Okay, there we go. All set. All right, anyway. There's a hidden menu that you can access on these. So if you ever have error codes, like it gives you pressure alarms, it gives no pumping alarms. If they say like, hey, you turned it on, it doesn't pump, or if you turn it on, you don't hear the valves clickety-clacking or the motor turning, then you go in the service menu and you can do a function check and a burn-in test, okay? So I'll show you what those are. There's a forward arrow and a B. So I hold down both of those and I turn the device on. Okay, you can see right there, it did not go into a boot up screen. It just beeps and there you are. It's right in the screen. So what you do is by migrating through these guys right here, you will change the error code. See the little arrow? So you press the arrow, T1, T2. Now T2 is like a function check / burn-in check, okay? So I like running T2, especially if I'm testing a unit before I put it back out if it's been sitting for a while. I'll run a T2 on it. So you can hear the motor starts spinning up and it's working the pressure relief valves, and it's also working the motor at different RPMs. And it's going to do that for a while. So let's check out some of the other options. It's been a while since I've been in there. I just remember T2 is like by default. Okay, so that's a normal boot up screen right there, guys. And I did not hit the buttons. Let's try it again. All right, there we go. Okay, so I'm gonna hit over. Let's try T1. Let's see what T1 does. I hear some relief valves clicking. Okay. So I can hear it's going through the different reservoirs, and we'll go over that. I'll tear this open and I'll show you guys the different pressure reservoirs inside. Okay, and it's going to do that for a while. Let's see what the other error codes are, or the other functions. Okay. All right, there it goes. Now I can see it. Okay, let's go T1, T2, T3. Let's see what T3 does. Ooh, okay. So here is where we can do a pressure check. Neat. So yeah, it is in millimeters of mercury, and it has been a long time since I did a PM on one of these. I cannot even remember how to do it. But as you can see right here, you can probably hook a jig up to these guys, these ports, with a syringe and do a pressure cal, I would imagine. Oh, there you go. Okay. All right. So I would have to read in on it, but if you get error codes when you boot it up, that's the first thing I would do is a calibration and a burn-in and see if that solves your problem. T4's ID calibration. Thank you, Ryan. I have not. It's been years since I've seen these stupid devices. Okay. T1, T2, T3. So you say T4 is ID calibration. I don't know. It's a subdued 0 millimeters of mercury. I honestly don't know what that is. 1845. Oh, cool. Okay, so this one here is going through the full pressure. Okay, T5. Oh, screen check. Okay. Screen check. Okay. So that's a cool little test. And it says at the end, it's good. What is this funkiness? I don't know. I wonder if this is to test out the detection mechanism for detecting the sleeve or the anklet or the arm. Okay. It has been a long time since I've been through these menus. Okay. T7. Looks like it's doing a sweep through the battery. Oh, so it's checking everything kind of all at once. You can see it's checking the battery, it's checking the screen. Okay. It's a good to know, I guess. Alright, so it doesn't like me occluding it. Oh well. Come on. Okay, so that was T7. It looked like it was a generic test all. Let's see, T8. And I have no idea what that is. There is a USB port on here. I wonder if T8. It's got a little human and a clock. I don't know what that one is. Okay, so I can flip through the error codes. Very cool. That's probably one of the coolest error code menus I've seen in a while. I wish it had a date and timestamp though. It would tell me if, you know, all these error codes happened in one instance or if it was over a period of time. But anyway, that is the functionality of the device. Let me tear into it because I have had to strip these guys down this last week. And my boss wanted me to go ahead and these are one stage away from being a pneumatic tourniquet. So technically these do have a PM, okay? They do. I don't know if your hospital will want you to do a PM. That's a whole nother thing. But these are, you know, they will give you problems. If there's any sort of issue with the device, it will error code for sure. But I would recommend a PM for sure. Anyway, let's see if I can whip out my screwdrivers here and find a good one. Is that it? All right. Wow, these things are a roly-poly device. That's for darn sure. Okay. So there's a weird thing that Covidien has done. So you can see on the fastener right there, there is a rubber O-ring. And I guess that is their form of Loctite, okay? Because as you squish it down, it prevents fluid from getting in, and at the same time, it keeps the screw from backing out a little bit. So one of the most common things that biomeds have to do is they have to change out these clamps. And because we have to do this so often, you get to be very, very fast at it. But one of the things I proposed, because my boss wanted me to ship a whole bunch of these out, or he wanted this secretary to ship a whole bunch out. And I told him, why don't we just take, you know, the ones that have good components, like power cord or a good clamp, move them over to the devices that, you know, have bad components, and that way there we only ship out a fraction of the amount. You know, yeah, it takes a little bit of time, but think about it. I don't remember right if Covidien does flat rate repair, but I bet you they do. And a flat rate repair is going to be hundreds of dollars at least. And the thing is, why would we ship out like 20 or so of them if we only have to ship out 7 or 8? It just doesn't make sense, not to me. All right, here we go. I remember. So there is a filter. You can see it right here. And we can clean those out. So when you're vacuuming this device, if you do vacuum your equipment, you have to be cognizant that you'll suck up that filter. All right. And if I remember right, you just press this and it just pops out. There we go. Yeah. Okay. So there's a wee bit of tension there, and there's a tiny little lip right here. See that? So you just rock it back a little bit, push it down, and it pops right out. And it's just the inverse for putting it in. So I compress it down like so. put it underneath, and put it back in. But I'll do that later. This is going to be all part of my teardown anyway. I've done many of these clamps. Alright, so that gives me full open access. You can see the cover that is holding the power cord on. Covidien. What a pain in the butt that is, let me tell you. The fact that it's 2 fasteners as well. If it was just one, Then they put the fasteners underneath the handle, so it's cumbersome to get in there. Just a pain. Come on. There we go. So there's another filter down here. You can see it right there. There is a USB port, probably for programming, for error codes and stuff. And the 90-degree IEC connector that I mentioned. So these things are just kind of a pain because the cord can back out. And when the cord backs out, then you will get intermittent power problems with the device, and it's a pain in the ass. So one of the ways to fix it is to take a little flat blade screwdriver, you stick it in the hole, and you kind of wiggle it while pressing down on it, and it will force the IEC back down. I've done that before. But a lot of cords nowadays have a bunch of nurses tape, eye tape and stuff on them. And so I trade out cords routinely anyway. So how I get the cord out is I take a little tool, the same tool I'm using to open the device. I stick it down here in this little gully, and I pry out while pulling on the cord on the other side, and it just pops right out. Too easy. All right, let's open this bad boy up. Considering the things I don't like about this device, it's actually a well-made device. It really is. I mean, liquids just kind of roll right off it because of its shape. Every single surface is curved. I mean, it's got good grip because it's got this butylene overmolding. I mean, everything is so nice about it. It's just everybody abuses them. When staff interacts with a device very often, they eventually lose respect for the device, even though it could be thousands of dollars, tens of thousands of dollars. So they lose respect for the device, and they just throw them around or crash it into walls or whatever. And these things are no exception to that rule, man. I've seen people chuck these on the floor, when they go to move a patient. I've seen these things get crushed by surgical tables so often. So often. These have damaged my surgical tables. Alright, let's see. I think that's all. So there's 2 fasteners up around the handle. There's one by the IEC inlet, and there's one over here by your ground, and there's one down here at the bottom. And I believe that's all. That's one of the reasons I like these mats, guys, because it keeps everything very localized. If you have a hard surface, things tend to bounce and just roll off. With these silicone mats, stuff just tends to stick. I do like that. And you can see it, the seam line right there, how it just breaks open so nicely. For all the things I don't like about Covidien, they do some stuff right. Alright, give me just a moment. I'm going to clip some of these zip ties so that we can see inside properly. So the first zip tie that you're going to have to clip is right here on this bundle. Just be careful not to clip the wires. Alright. Let's see. So right now I have silicone tubing. You can see it right here. It's holding me, so I'll just grab onto it, give it a little bit of a pull. And there's another zip tie. This one down here is a pain. Alright, just make sure when you reach down in there, can you see it? Right down in there. So this one here, I've actually seen techs cut wires on accident because they just reach down in there and start cutting. You can't do that. You gotta be careful. Alright, let's see. We are getting into the meat and taters now. All right. I want to disconnect this completely. That one. Hold on. I got another zip tie. That's one secured device, eh? All right. Here we go. Here we go. All right. So you have your control PCB, and you can see the connector right here for your membrane buttons on the front. This guy here, I've seen this have problems before. This right here is your pressure sensor, okay? Hope it showed up. Yeah, right there. This is your pressure sensor. It can be recalibrated, and I don't know if you want to be zealous enough, you can actually order that pressure sensor. I think there's a part number on the bottom of it, if I remember right. And you can replace that if you want to. I like that they put some hot snot right there on the capacitor to keep it from bouncing around. Good idea. And there is some hefty standoffs. If you look underneath, right there. So you can see how the motherboard or the CPU board is being held away from the front face. So any impacts that happen on the front face, which do happen, they're not directly impacting the backside of that board, because multi-layer boards just do not like being flexed. Let's see. We got our video outfeed is right here on this connector. And this one looks like it's a little bit skewed, just a tiny little bit. So I'll probably try and correct that before I put it back together. And your display is hidden up under there. So 4 screws, you can take it out and you might be able to get that display. I don't know. So that is pretty much it for the CPU board. Oh man, take a look at what's going on over here. All right, so as I said before, we got our pressure line. It's a pressure sense. And let's see, can I show it to y'all? So up under here, there's a whole series of different pneumatic valves, and those control all the different chambers up here on these two connectors. So remember, there's 3 different chambers because it's sequentially compressing the legs. So we have 6 little air solenoids right in there, right? Oh, let's see. Here is the pump. Let me clip some wires and pull this guy out. This thing's got a cool pump. Here, I'm going to disconnect a couple more things. So one of the things I do like about these guys is it's all silicone tubing, so stuff just pulls apart. It's so nice. Here we go. A little more proof that these guys build these things rather well. Take a look at the foam. Now, not only is this foam adding damper to the motor assembly, it's isolating the noise of this little motor. It does a pretty good job too. So this looks like it is a typical brushed DC motor. And there is, are those piston pumps? There you go. We're gonna open them all up. Let's go ahead and take a look. They're probably diaphragm pumps. I think I see a diaphragm there. Before I pull this head off, take a look that there is directional arrows on it. So it's got vacuum and it's got pressure. All right, come on off. All right, there we go. That would be a diaphragm pump for sure. So there's your diaphragm. It does feel like there's a weeble wobble piston underneath it pushing up on it, but it's a diaphragm pump nonetheless. And on this side, you can see our portholes. And hold on a second, let me see if I can separate those out, because there is going to be reed valves underneath this. Boy! And there we go. All right. So we have flapper valves or reed valves right here. Let me get a smaller screwdriver. So, you know, anytime you want to pump anything, you have to have an inflow and outflow. All right. So you can see that this one here binds against the upper porthole right here. And then this one here is for exhaust. So this one here is for suction. This one here is for exhaust. Boop. Too easy, man. Very simple design. And these things are just fantastically reliable. I hope the camera's picking this up, man. But just take into account that there is some debris that always gets up on these flapper valves, and you can clean them off. All right, just take a cotton swab, something like that, with maybe a little bit of alcohol, and roll it on the surface of those. Make sure you don't damage them, and clean them off, and that will help it seal a little bit better if it's not maintaining pressure. I'll just go ahead and leave that off. Why not? Let's take a look inside the motor housing. So I predict that it's got like a weeble wobble piston based on, it's operating two pump heads at the same time. So let's go ahead and take a look and see what's under this cover so we can figure out what it's got. Such a cool little pump, man. I really like these. It's a good project pump. All right. Wow, look at you. Okay. All right. So I've never taken one of these apart before, guys. So you can see right here that there is a offset weight that's screwed into the shaft. And it looks like, yeah, there's two pistons. There's one piston right here. There's one piston right there. And they're operating the diaphragms. This big fastener is offset weight because this guy, if you take a look, I wish I could touch the other side. So it's got like an eccentric cam. Yeah. So that's pretty much it. So it balances out quite nicely, I guess. I wish I had my DC power supply hooked up, because then I, could hook it up for you guys and turn the voltage way down so that we can actually see it run kind of in slow motion. Soon enough, guys. Soon enough. Maybe tomorrow. That's what I'll work on, is finishing up my workbench. Today I just had like a humongous Nerf war with the kids. So all day long, like, we're building cardboard forts, and I was terrorizing them with the new Nerf rival guns, and it's so much fun. My kids are nuts. So this guy right here, this big guy right here, is an air reservoir. You see that? And you can see the manifold right up here. So there's a plastic manifold up here in the front, and that is feeding all your little solenoid valves. And the solenoid valves direct output straight to the output. So, and there's what, one water separator or a contaminant separator right there. Let's get down to the hardy parts of her. So this is the power board, and that's almost it, man. We're almost done. Hold on. More zip ties, guys. More zip ties. What is the deal? Covidien. I love zip ties, man. But Covidien just takes it to another level. Come on. There we go. All right. Now I can pull the wires out of the way so we can get a proper look. Let's pull the battery out. All right. What do we got here? So these things are using a lithium-ion battery pack. This is it's a 6-volt motor, so I guess the assumption is 2 3-volt cells. Oh no, check that. Wow. Okay. I wouldn't have suspected that. It's got a 10.8 volt, 2200 milliamp hour lithium ion cell. That's good to know, man. Because every once in a while we do scrap these things, and some of these battery packs might prove a little useful. So that's a lithium ion battery. Let's pull out the power board. I'm just nuts about power boards. You guys are probably tired of hearing me talk about them, but I do love some power boards, man. All right. Wow. Okay. Devil's in the details, man. So if you take a look, there's a foam surround on the IEC AC input, which is soldered directly to the PCB. So if you are having no charge issues, you could either have fluid intrusion, or if somebody is yanking on the cord, you might actually crack one of these solder joints. That's interesting. I didn't expect that to be soldered straight to the board. Okay. So your AC power comes in, you've got your filtering, you've got your variable resistor for inrush current limiting. We have your bridge rectifiers right here, this little tiny chip. So it's obviously not working very hard. And there, let's see, that's a controller chip. This is obviously your MOSFET, your power MOSFET, your transformer, DC out. Okay, all right. And there's some good test points on the back of this. So you can see there's a test point for VCC, for, I don't know if that's forward bias. There's FB, there's test point 10, 11. I mean, there's a ground test point right there. I mean, these guys did pretty good. ACN, ACL, VIN. Interesting. Maybe I'll put this guy in a clamp so we can check it out. So I see plus 24 volts. We got plus 5 volts over here. So you could actually check it out and maybe fix it. U2, I see a couple diodes. Not too much to it, man. Definitely not too much to it. Interesting. So I myself have had a couple problems this week with devices that would not charge, didn't recognize that the AC was plugged in, and I'm not seeing any fuses. Oh, wait. Is it built in? I've got it written right here. It says 1.6 amp, 250 volt AC slow blow fuse. And I don't see this fuse. So it must be under the shroud. Hey, take a look at that. All right, so there they are. So it has both. Remember when I was telling you guys that devices that are going to be used in surgical operating room theaters often have both hot and neutral fused in some fashion? Well, here you can see it on this guy. So there it is. That's very nifty, a fuse cover. I like it. Wow. So not too much to her, man. I think the rest, we have a little tiny cooling fan right here. And the USB input, which is going to go up to your CPU board. But that's it, man. That is a 700 series SCD. That's pretty cool. That is going to have to go in the project bin because I have another antiquity to open up for you guys and show you some other cool stuff. Because I had to separate parts from one device to the other just this week to salvage something. So I'm going to take it back apart is show you guys an intracranial pressure monitor. Oh, gold. All right. So at work, I keep plastic bins for when I take something apart, and I put all my fasteners in Ziploc baggies. I don't have that luxury here because I don't have Ziploc baggies and I don't have the plastic containers, but I do have this box. And this box is going to do me well. I'm going to put all the components back in so I can assemble this tomorrow. I'm not going to bore you guys with a full assembly of the device. All right. So whenever I have somebody in my shop that takes something apart, I always tell them, put all your components in those plastic organizing bins that stack. Put all your parts into that one bin, and then put all your fasteners in a Ziploc baggie. Put that in there too. Okay. Do we use RFID trackers on these? That would make sense, and maybe this will change. RFID trackers are very expensive, and I just don't foresee my contracted management spending that kind of money on those kinds of things. There's been some real major development just this week in my shop at work, man. The head boss for my contracted management, his position was eliminated, and I'm actually kind of upset about that because I thought he was a good boss. Just under ideal circumstances, I think he would be an excellent boss. And you don't see people like that all the time. Everybody's got their quirks, and he had high expectations and everything, but I mean, who wouldn't? Who's in charge of millions and millions and millions of dollars on an account? So kind of sad to see him go. But I guess, we never know who the next guy's going to be. So, all right. Let's see here. All right. So, one of the things I always try and do is I always try and put my tools immediately back, even if I'm going to use them on the next device. I don't know if I will or not, but just in case, I always put my screwdrivers back. And whenever I had these on my workbench at work, it would kind of drive me crazy because I would be missing one. If you're missing one, you can see it, and it just eats away at your eyeballs. That, hey, I'm missing one. Where's my screwdriver? Then you start hunting around the shop to figure out who borrowed your screwdriver. I don't care if people use my tools, but please, for the love of God, put them back. All right. So this is a Covidien intracranial pressure monitor. It is a staple of our career field going back 20 or so years. Man, I don't know how old this guy is. Maybe we'll find some evidence on the inside, but it's probably, I don't know if that's 1998. Anyway, these things are still in use. They're definitely still in use, guys. And I had a couple of them that I had to babysit. I would take 2 units that are down for whatever reason, and you take parts out of one, because I don't even think you can get parts for these anymore. The cases are starting to get brittle. Just in general, they're, getting old. Look at those fasteners. Do not lose these fasteners, guys. You're not going to find more like that anytime soon. All right. So to break this guy loose, you take out those 2 fasteners, and you can see how I just slightly pry up on it a little bit, and it comes right off. Have you guys ever opened up a case and you've seen that it's got like this copper type of coating on the inside, and you think, wow, that's really pretty. Why would they do that? there is a purpose for everything because that adds cost to production. That is actually a conductive coating, which I could prove with my multimeter. And you've seen in like my power supplies and stuff that I brought up here before that they have like a Faraday cage around them to limit RF energy, so it's an RF shield. Well, these devices have their own type of RF shield, which is this copper type of spray coating, which I'm not even sure if it's sprayed or if it's dipped. I assume it's sprayed on the inside. So it's shiny, it's pretty. Take a look. You can see a date. You can see that. So I got what? 07/23/12. Okay. So this guy's old. It's getting there. It's what, 9 years old? It's had a good life. It's had a good life. But that's alright, because this guy's still serviceable. I'm just doing this to show you guys around. So inside this bad boy, the one thing that we have to be careful about is these fasteners right here. Hold on one second. Hey, what you doing? What you doing? You're getting fat. I already fed you. All right? Already fed you. All right. As I was saying, there's 2 nylon fasteners, and you have to be careful with those, especially when you're putting them in. Don't use power tools. You will booger them up. All right? So I use hand tools to take them out and put them in. All right. So it's them. Got the shield that wraps around. And let's open up this board. This device, here, before I open it up too much, there's also nylon spacers in there, so that's why it's good to do this over a mat. It catches everything that falls out. You can see the spacers right here on this side. So those nylon spacers were for those nylon fasteners on the other side. But there are 3 different layers. I got a power board. I have, I think, a pressure monitoring board, and then there is a control board. So we're going to open them up so you can see. Now, one step of this disassembly has already been done. On the outside of the machine, there is a RS-232 serial port, and there's normally 2 screw down lugs. I've already removed those. Let's see. I've got a little connector right here. Come on. There we go. Ouch. All right. Well, that didn't go as planned. So you can see that I've got a, man, that's the thing about taking apart old equipment. You never know what's going to happen. Come here, you. There we go. So these older style wiring connectors, there's actually little metal V's in there. So you lay your ribbon cable down and you pinch it, and that's how you get your conduction to all your pins. You got to be careful of those. And as you just found out, as I started taking it out, stupid thing exploded on me. It came apart. All right, and definitely pull straight up when you take these apart, because there is a connector right here which joins the 2 PCBs together, and that's interesting. Does this thing have high voltage? Anyway, Oh, we'll get into it a little bit more. This is obviously got some of your communication on there. I'll have to read in on some of those chips to figure out what the hell they do. Lots of old school ribbon cables, man. Alright. And here is where I have this cool tool. It's part of my kit. It's got a little fork and it's got an angle. Because sometimes you have stuff like these jumpers that you just got to get underneath to pull up like battery terminals. So there we go. So these intracranial pressure monitors, they do have a regular PM, and every couple of years you do have to change the batteries in these stupid things, and not too many people do. So you have to get used to taking these things apart. Your CPU board. Yep. Nothing too special. You just have to be really aware of all the fine pins that are around. And they put a lot of connectors. You can see that it's been stressed before. See how they're at an angle? So just got to make sure that they haven't been too stressed. And don't pull up on any boards until you're absolutely sure that all these wire connectors, this guy over here, are all disconnected. So that is the CPU board. Very cool. All right. Oh, now we're getting into the lovely part of it. The batteries. We can finally get down to where we start releasing some clamps. It's kind of crazy that you have to go through this kind of labor every 2 or 3 years. All right, here we go. Okay, just be aware that you don't want to lose those screws. Okay. And you can see by the date on this one, it says 1 of 17. So this is an old battery. This one's going to get changed out before it goes back into service. And I honestly don't have to pull this apart any further, because right there's your power PCB. Oh, and this one's adjustable. How cool is that? That's some old school stuff. So your AC power comes in. Oh, look at that. All right, okay. Very interesting. Okay, so the AC power comes in and it wraps around the outside, comes around to this connector over here, where it goes into a step-down transformer. And I know that what date did I say was on this thing, man? It says 07/23/12. Guys, when I say that these are some old school meters, I was not playing around. There is a date on this power PCB right here, and it clearly says 1989. Let's see it. Anyway, I understand that that's when the copyright was filed for the board, but it was designed, 30 some years ago, regardless, if not manufactured 30 some years ago. Yeah, there's some other build stickers under there. I'm not going to get into it too much. Yeah, it's an old girl, that's for sure. So it goes into a step-down transformer, and then next to it, I'm almost thinking that is a isolation transformer. Just based on the type of wraps. It looks like it's, looking at the gauge of the wiring from what I can see here, it looks almost like it's the same gauge. Usually if it's step up or step down, the gauge or the diameter of the wiring will get bigger or smaller. Now from what I can tell of the imprint on the wrap, looks about the same. If not, then it's a step-down transformer. But then the fuse for it is right here on the back side of the transformer, which is unusual. And I said earlier that if you don't have a bridge rectifier, then you can expect to see 4 diodes, and that is right over here. So there's four diodes here, and whenever you see a giant capacitor in a power supply, that is almost guaranteed to be on your high voltage DC rail, which is right after your bridge rectifier or rectification. So from in there, man, I kind of want to pop that board out, so I'm for surely telling you guys the correct way that power goes through. But in the end, the cool thing about this board that you can see right there, oh, right down there, it's adjustable. There's a trim pot right there. So you can adjust the output of this power board, I guess. I don't know. But you can see that there are some glob CPU chips on the back side of this board for the display controller. And what is this? Yeah, okay, so this is just a membrane switch board. But anyway, intracranial pressure monitors, they do have to be calibrated. They are a sensitive device because it is what it is. It's intracranial pressure monitoring, okay? So whenever there's trauma or whenever it's post-surgery, they have to monitor the pressure inside the cranium because it's a sealed container, and your body normally regulates the pressure inside your head. But when you're comatose, catatonic, when you have trauma, bleeding, hemorrhaging, those are all instances where your body can't naturally control its own temperature or pressures, so that's why we monitor them, all right? So that's an intracranial pressure monitor. And what a cool device. Anyway, I wish I had the probe to connect on the front of it so that I could run it through like a 0-cal and everything for you guys, but I didn't bring any of that stuff with me because what I had to do is I had a unit that was constantly beeping whenever the battery was plugged in. Every single time. As soon as I plug it in, it starts beeping. It was so annoying. So this board right here, your CPU board, it obviously, since it's a CPU board, it controls your alarm signals, okay? Well, something on here was latched on, and it did not like it. So I had a unit that had a cracked case and fractured display, if I remember right. And it also had a power supply issue. So I was able to take the CPU board out of the unit that was cracked and it had a charging issue, and I was able to place it into this machine, and before I took it apart just a moment ago, it was working. So anyway, but very cool device. It's got some old school stuff that you don't see anymore. Like right here, you can see your battery leads go through the PCB and they're soldered in. You would never see that nowadays. You would never see that. It's crazy. So I love tearing apart old stuff like this because it kind of takes me back. I've been doing this for almost 20 years now, so when I go back to like pre-surface mount technology, I just love it, man. So anyway, that is pretty much it for an intracranial pressure monitor. And it's a cool little device. You don't see them that often anymore, I guess, but only thing to take out of this is that there is a battery inside it. Has to be changed out, okay? Anyway, you guys, I'm looking right now to see how bad the lag is because with the old computer, the lag was longer and longer and longer. And I think it stayed around 30 seconds lag throughout this whole presentation, and that is damn good. Because it used to be with the computer that I've got mounted on my wall, it got to like a minute and a half lag. It was crazy. But anyway, guys, I am on call. All right, yay! I'm on call again because I took call from an associate that had undergone an emergency surgery, and it's just, if any of you guys are or going to be senior level biomeds, I just hope that you guys take into account that there's a lot more ancillary responsibility that goes along with that. And that includes stuff like this. Whenever somebody's got a family issue or whatnot, it's always, I don't know, maybe it's a military thing, but we're always gonna, step up, especially if it's one of our teammates. Usually the most senior technician is going to step up and take their call when something happens. So I hope that if you guys that are junior biomeds become senior biomeds, I hope that you guys understand that and, take care of you guys, all right? Anyway, guys, I'm going to work on my workbench and see if I can straighten it up a little bit. As you can tell, I'm in comfort mode because at any moment I'm expecting my phone to go off, even though it's been a rather quiet weekend so far. So anyway, Covidien, where you been, man? Those Canadians are always late. But anyway, guys, I'm gonna let you guys go. I've got some other really cool stuff to share with you guys soon. I'm waiting on some new parts of my toolkit to come in, and I'll give you guys a very cool briefing on some new tools. And it's again, I'm changing my toolkit just a little bit, and some new stuff is coming out that's, I think, is going to be a game changer for us as biomeds. So I took part in that. I pre-purchased, and I'm waiting for some of that to come in. But anyway, guys, you all have a wonderful evening, and I hope to see you guys on the next stream, all right? Thanks for joining us. And I do have some other videos that I'm working on, which I have to go in and write the script for, so that I can start the production, because I have a couple more biomed basics type of things I want to share with you guys. All right. So that is going to happen tonight. I'm not going to sleep. Anyway, thanks for joining the stream, guys. Y'all have a wonderful evening. All right.